Hi everyone, and welcome to this video for PROG1198 Client Server Solutions. Today's topic is stored procedures. So we're going to take a look at what stored procedures are and why we might want to use them, and how they differ from some of the other database objects that we've learned about in this course. So a stored procedure is a named collection of TSQL statements that are stored on the server. That's where it comes from. And it's a method of encapsulating repetitive tasks. So it's similar to writing a function or a method, but the difference here is that when we write a function, like a user-defined function in TSQL, the point of the function was to return something, either returning a value or returning a table. A stored procedure doesn't have to return anything, so it doesn't have to generate any kind of tangible result that you're now looking to make use of. Instead, it's used for performing some task. So we say that we call a function to get something, and we call on a procedure to do something. Stored procedures can support user-declared variables, conditional execution, and pretty much any TSQL statement that you can think to write. We use a stored procedure mainly to perform operations in the database, including the ability to call other procedures. Stored procedures can accept input parameters. We also have something called output parameters where we can return multiple values. Both of these things are optional, so you can choose whether or not you want to have input parameters or whether or not you want to have output parameters. And typically we might want to also return a status value to indicate whether the procedure succeeded or failed. And we can do that through a multitude of different ways. Some of the advantages to using stored procedures. First and foremost, it allows us to avoid repeating code. So if we have certain actions that we perform on our database every day or every week or every month, rather than rewriting all of those commands each time, we can store them in a procedure and then call the procedure whenever we want them to run. Or we can even automate that step as well, so we can write a little program or script that calls the procedure for us automatically on a timer. We can use them to encapsulate business functionality, and we can use them to hide table details. So for example, users might interact with our database system entirely through stored procedures, and then the user wouldn't need to know the specifics of how our tables are created or how they're related or what even the field names are. And we're going to be using this particular advantage later on in the course when we move into working on the client side. Once we get our client established, we're going to make it so that our client interacts with stored procedures so that the client is ignorant of the underlying database structure. So it works well as a security mechanism as well. You can't do injections and things like that if you don't even know the name of the table that you're working with. We can use them to improve performance, and we can also use them to reduce network traffic. Rather than sending 5 or 6 or 8 different commands across the network, all we have to do is send that one command that says run this procedure, and the procedure that's stored on the server will run all those commands for us. So they're a really, really useful part of a TSQL system, and that is why we've left them to the end. So if you don't know whether you are supposed to be writing a stored procedure or a function, you can consider this little checklist here. So things about stored procedures that may differ from how you use a function. Stored procedures are not required to return anything. Stored procedures can make changes to the data, so you can perform insert update statements in a procedure. They can set multiple output values. Remember that a function can only return one thing. Stored procedures can use transactions and can use try-catch. So you can put all of this logic into your procedure to make sure that it works, to respond correctly if something failed, all these things that you can't necessarily do inside a function. So when we want to create a stored procedure, this is a database object, something that we create once and then call on as needed. So we use the same create syntax that we're familiar with when we're creating other database objects. So for example, we start here with a create statement, the word procedure, and then we give our procedure a name. Typically the name starts with either SP or USP underscore. Then we have a list of input and output parameters. The parameters are optional, So you can list as few or as many as you want, and you can determine whether they are going to be input parameters, that is, they start the procedure by giving that parameter a value, or they can be output parameters, which means the procedure's job is to set the value of those variables. And then we have as and our program statements inside the procedure. So very similar syntax to creating other database objects. Now here's an example of a very simple stored procedure. This one doesn't use any input or output parameters. And what that means is it's going to execute the same way every time. This procedure uses the Northwind database. Now I don't think we've done any examples in Northwind yet. If you're not familiar with it, Northwind is a database that was created by Microsoft to use during their examples and demonstrations. So if you go to the Microsoft development website, you know, their help and their documentation, a lot of their documentation used this Northwind example, so I figured I would bring it in here. If you don't have this database yet, you can download it from the databases link in Blackboard. It's there at the bottom of the list. So this procedure is called overdue orders, and the program statement is just one select statement. It says select all from orders, orders is the name of a table, where required date is less than today's date, and shipped date is null. Now if we take a look at what this means, it means that the order was required before today, but it has not yet been shipped. And that's what makes it overdue. Something should have been shipped yet, but wasn't. This is something that we might want to run every morning when we start our day at work. We want to find out, are any orders overdue? So by creating this procedure, we can call on it, and we wouldn't have to rewrite the select statement every day. All we have to do is execute the procedure. So I'm going to put this code into our SQL Server window. So here's the line of code that came from the slide. We're going to create this procedure called overdue orders. Now, just as a reminder, when we create these, we're going to be following the naming conventions. So I'm going to say USP _ overdue orders. Microsoft doesn't follow that on their demonstrations, but that doesn't mean that we can't. So I'm going to execute this to create the procedure. Once it's created, it exists in the system. If you ever want to see what kind of stored procedures you have, you can look in the programmability folder under stored procedures, and you'll see that when you download this database, it already comes with a bunch of stored procedures, but here's the one that we created called overdue orders. So once it's created, you don't have to create it again. If you want to make changes to it, you can change it to an alter statement. And you can execute this to change what the procedure statements are. So now that it's created, whenever we want to execute it, we want to call the name of that procedure, just like calling a method or a function. So we can execute a stored procedure either by itself or as part of an insert statement. So we're going to look first at executing a stored procedure by itself. We issue the execute statement along with the name of the procedure and any parameters. So we have the word execute, or you can use a shortcut exec. You can leave off the UTE, it's optional. The schema name is also optional. Usually this is DBO, but again, you can leave it out. The name of the procedure, and then after calling the procedure, you would provide the list of parameters. Now, our example procedure, overdue orders, didn't have any parameters, so all we would need to do is call to execute overdue orders. So let's go back here, and we're going to execute it. So we can type execute. And this is all we need to do to execute that procedure. When we call execute with that procedure name, this code in here runs. Or you can say exec. So if I run that code, we can see how the select statement where the required date is before today and the ship date is null, that query executed. And you can have as many statements as you want in your procedure. I mentioned this already. If you want to change what the procedure says, just modify to use the keyword alter. If you want to remove a procedure, use drop syntax. Keep in mind you can only alter or drop a procedure if you have permission. So if you were the creator or you have explicit permissions on that database. Now let's take a look at using parameters on a procedure. We can have two types of parameters, input parameters and output parameters. So an input parameter allows information to come into the procedure. We declare them as parameters in the create statement. So they go after the create line, but before the as. When we want to define a parameter, the syntax for it is we give the parameter a name. And remember that variable names in SQL start with the @ symbol. So we give it a name, and then we specify the data type. And optionally, we can specify a default value. If we specify a default value, then when the exec statement is executed, the user has the option to leave that parameter out. And if they leave it out, then it will get assigned its default value instead. Now this has nothing to do with default values on table data. We can assign a parameter default to whatever you want. One thing to keep in mind though, when you're assigning defaults, it has to either be a constant or null. So you can't assign a default that requires a call to a function. When we're passing parameters in the execute statement, we can pass them either by name or by position. And we'll see an example of that soon. So this example here creates a procedure called year-to-year sales. It returns all sales between specific dates. So we are going to pass in two input parameters for dates. First one is called beginning date, and the second one is called ending date. So here's our create statement, and then after that, our parameter list, the name of the parameter and the data type. And here we have a comma separating from the next parameter, the name of the parameter and the data type. When you're specifying the data type, don't forget that you also need to provide the precision or the scale or the size. So if you're doing, say, decimal, make sure that you provide the size of the decimal as well. Now take a look at the program statements. The first thing we see here is an if statement that checks for nulls on these two dates. So it raises an error if either one of the two dates contains a null. So this procedure will only actually select anything provided that you provide two valid date objects here. If they're null, then we get an error message, and the return statement ends the procedure. So just like in many other programming languages, when you hit a return, it means go back to where you came from. So the procedure wouldn't continue if one of the two dates is null. Now, if one of the two dates is not null here, so that means that both of them are not null, then we're going to execute this select statement. So the select statement selects a bunch of things from an orders and an order subtotals, where the shipped date is between, and you'll see those two parameters down here. Let me just get my highlighter out. This one and that one. So the parameters change how the procedure runs. You know, if you have a beginning date of April 1st, 1990 and an ending date of March 31st, 1991, then that's going to give you a different output than if your beginning date was January 30th, 2003 and your ending date was February 28th, 2004. So we have those options of changing the behavior of the procedure based on the input parameters. So let's see an example of this one in action. I'll just put the code into our window here. Okay, so I've put the code from the slide into SQL Server here. But before I execute it, you might notice here that we've got a little bit of a red underline happening here. Order subtotals is not one of the tables in Northwind. In fact, it's a view. So if we take a look at the views here, you can see that there's several views created. We've studied views before, and we know that they're basically just a wrapped select statement. So we can see the order subtotals view here. There is a space in the name. That is Microsoft's doing. That's the way that it comes when you download the Northwind database. So we can get to that view. You know, it's not the name of a table. Now, we know if we put a space in it, this is going to cause another problem. So typically what we can do here is you see how it starts to recognize that I'm trying to select from that view. So we can use our square brackets to indicate that we're joining the orders table to the result of that view. Now, if we look down here, we can see what's in the view. If I select all from order subtotals, we'll just execute this. So here's what we see for every order. There's its subtotal. Now, the orders table contains this data: what customer it is, what employee it is, some things about the dates. You can see that there's no information here about prices or anything like that. That comes from order details, and rather than performing all these complicated joins, we've just joined it to the view order subtotals so that we can display the subtotal for any given order. I'll just comment these out for now. We don't need them, but it was useful to get a bit of insight into how the table actually works so that you're, on the same page. So here's our procedure. Now we can try to test this out before we run it, but the thing is that we're not going to have values for beginning date and end date just yet. Now, if we wanted to test the select statement, we can just hard code in some values. So I don't want to lose what is written there, but we can test the select statement by putting in some temporary dates here for the shipped date between January 1st, 96 and December 31st. So this is, all the orders during 1996. So we can test that out, make sure that we're getting the results that we want, and then just replace those test values with the parameters. That way later when we run the procedure, if the parameters don't appear to be working, we can isolate where the problem is. We know the problem isn't the where line. We already tested that out, right? So let's just comment out this. We'll swap this around and line everything up. There we go. Okay, so I'm going to execute the create statement to create the year-to-year sales procedure. And again, this naming convention is done by Microsoft, so it's a little different than what we're used to in this class. But I wanted to kind of expose you to that just because, when you're using TSQL and you're using SQL Server, all of the documentation and everything is written that way. So we will see that. So we're creating our procedure. Now when I want to execute it, I'm going to need to call it by name, year-to-year sales. So the execute statement starts off like this. But you can see that I'm not done, because if I try to execute this thing without providing beginning date or end date, I get an error message. It's expecting those parameters, and we're not giving them. So that's a problem, right? And you can see it recognizes this, that it's expecting that beginning date. So there's two ways that we can provide values for the input parameters. So one of them is we can pass them by position. That is, we just pass them in the order that they're written in the procedure. So if I pass in two dates, 1996, 01, 01, and the second one, 1996, 12, 31, then we can pass them in positionally. This one is the first parameter, so it will become beginning date. That one is the second, so it becomes ending date. So we can execute the procedure like that by passing the two values in by position. and they just go in order from left to right. Now, the second option is we can pass them by name, and we'll see that example coming up on another slide. Now, here's a more complex example. This procedure performs an add customer. So this procedure has a lot of input parameters, and you can see some of them are assigned default values. In fact, all of them except the first two. Typically, when we create a procedure that is meant to add something to the database, we want to make sure that we provide a parameter for every field in the table that we're adding to. So if we're adding to the customer table, the add procedure needs to take a parameter for every customer field, even if you're not going to provide them all, because we still have to have that functionality in case we do want to provide a value for each one. Typically, the assignment of null as a default would match up to whether or not the field in the table allows nulls. So for example, if you couldn't add a customer with a null country, then you wouldn't provide a null here. If the country can be null, then you allow for that null as a default. Now this is only the first half of the procedure. You can see that this is just defining the parameters. The as line, after that, this would where the insert statement would be. When we execute it, here's an example of passing parameters by name. So when we go to execute that procedure, we can choose to pass them positionally, but because there are so many and because we're allowed to leave so many of them out, sometimes passing them by position can get a little confusing. So we can pass them by name. You specify the name of the parameter, equals, and then the incoming value. And this allows you to bypass or ignore some of the parameters. And if those parameters have defaults assigned, then the procedure will use the defaults instead. If the parameters do not have defaults, then you can't leave them out. So for example, you can't call add customer without providing customer ID and company name. They don't have an assigned default, so you have to provide a value. Those are the only two that are required. These other ones are all optional. If you leave these other ones out, they will use null. So let's apply that to what we see over here. Neither of these have default values, so that means they're both required. Instead of passing them positionally, we can pass them by name like this. So we can pass beginning date equals that and ending date equals this. I'm just going to hit enter so that we can see everything on the screen here. So this allows us to pass the parameters by name. And when you're passing them by name, they can go in any order. So if I want to put, for some reason, the ending date before the beginning date, because I'm assigning them by name, this is allowed. If I didn't assign them by name, they automatically go in order from left to right. So then this would be beginning and this would be end. So there's benefits to assigning by name, but it does require more typing. It makes your script longer. So you choose which way you think works best for you. So here's an example of that same execute statement for add customer, passing the values by position. And you can see how this might get a little bit confusing when there are so many parameters, making sure that they're all in the right order and in the correct position. And notice the null here, that in order to keep them in the right order, this was the region. And if you didn't specify null for region, then the next one, which is the postal code, would have been assigned to region. And then this one would have been assigned to postal code, and it would have shifted everything out of position. So when there are a lot of parameters, or when you have optional parameters, usually it's better to pass them by name. Now let's take a look at output parameters. Output parameters go the opposite direction. So you don't have to provide a value for them when you're calling the procedure, but the procedure itself creates the value for that parameter and is expected to pass it back. When you create an output parameter, you have to mark it as output in both places, in the create statement and also in the execute statement. And the execute statement, which is the call, has to contain a variable to receive that returned value. So let's take a look at this little example. Now, this example is very, very simplistic, but hopefully it gets the idea across about a procedure. Now, in the real world, we would create a function for this, not a procedure, because what this procedure does is it calculates the product of two numbers. So the product meaning I'm multiplying two things. Because we're getting some result, typically this would be a function. But I wanted to demonstrate very simplistically how a procedure can return one or more output parameters. So on the left we have the create statement, and we have three parameters. M1 and M2 are input parameters. But result, you can see that it is set as an output parameter. Now, the code of the procedure says we're going to use a set statement to assign a new value to result. When you have an output parameter, you must perform some kind of assignment to it, either in a set or a select. So we're taking the values of M1 and M2, multiplying them together, and we're going to assign that value into result. When the procedure ends, it passes result as output. Now let's take a look at our execute statement. We're passing three parameters. Passing them by position, the 5 becomes M1, and the 6 becomes M2, and the output parameter, we have to pass a variable. So up here, we have to make sure that this variable exists before we try to pass it. We say that it's an output parameter, but calling the procedure is what assigns the value to this variable. So after the procedure is called, we'll be able to see that the answer got assigned. So it's just like calling a function. So 5 becomes M1, and 6 becomes M2. And down here, we're going to have 5 times 6 being assigned. So 30 becomes result, which means that the 30 gets put into answer. So our output here is going to say the result is 30. Let's test it out in TSQL. So we'll write our create statement. And let's say USP underscore. Need to make an A here. Helps when you spell things correctly. It's always a good thing to do. So we're going to create those three input parameters. Small int for M1 and M2. And result. But this one is an output. Now notice there's not a return statement here. Oops, I need my 2 and go. So we'll create that procedure, and when I execute it, you'll see that I can't execute it without the M1 parameter. So if I provide a 5 for M1, then it's going to tell me, well, you also need M2. So if I provide a 6 for M2, it's also going to tell me that we need a result. Now, result is an output parameter. I can provide any name that I want. The names don't have to match up. So it's just like, in any other programming language when you're calling a method, it's not the name of the variable that passes, it's the value. So these are passed by value, and I'm going to declare some variable that makes sure we use the same data type, and we say that this is for the output. So the result that is being declared as an output here is going to end up, because that's the third parameter, this one's M1, this one's M2, and this one gets the value of result as an output parameter after the procedure is finished. Now, if we want to test out to make sure that this actually got assigned its value, that's where we run the print statement. So I can execute that, and you can see there's the 30. And if I change the input, if I do 2 times 8, for example, then the output will change as well. Now, like I said before, because we're just retrieving one single scalar value, that actually would be much better as a function. But I wanted to do a simple example of output parameters so you can see how it works in a stored procedure. Now that brings us to the end of the first set of slides. I'm going to move on to talk a bit about standard stored procedures. So what is the difference between a stored procedure and a standard stored procedure? Well, typically there is no difference. But when I talk about standard stored procedures, what I mean is a set of procedures that follow a particular set of rules and regulations and reasons for existing. Essentially, we would create a set of standard stored procedures around every database table that is going to be accessed by some kind of outside client or user. So, the most common standard stored procedures that we would create are to encapsulate our tables, to make them available to either a client or to a user who doesn't need to know the specifics of how our table works. So instead of saying, yeah, sure, you can add things to our table, here's how you write an insert query, and giving them full access, what we would do is say, yeah, sure, you can insert things into our table, call this procedure. All they have to do is pass the parameters. We control the insert statement and how it works. So it provides a layer of security and a business layer around our tables. So for every table, we would write a set of common stored procedures to return data for a single record, return data for all records, to return a set of lookup data like for drop-down lists, or optionally, we would return data with filters. So we're going to take a look at all these different types of procedures to return data. Those are going to be select queries. And also, we're going to provide procedures to encapsulate the action queries. So 3 procedures for that, 1 for insert, 1 for update, and 1 for delete. So the 3 options here we have for select procedures are for selecting with no restriction, that's selecting everything. And we might decide to include lookup values from related tables as well. So for example, if you consider our company database, we had a list of employees. If we want to select all the employees, we might also continue selecting their associated department names. Another option is to select one employee by primary key value. So that's a really important procedure that allows you to select one unique record. And those procedures are important because you might select one record to get more details about it, or you might want to perform an update on it, or you might want to perform a delete on it. And some additional select procedures could be created if we regularly filter the data based on different criteria. So for example, we might create show all employees in a given department, and we create a procedure that selects everyone based on a department code. Or select all employees hired within a certain year, and we provide the year. So if we have common filtering actions that we do, we might encapsulate that in a procedure as well. And one of the more advanced ones is going to allow for dynamic filtering of data. So it will allow us to search, find employees whose names begin with this letter, who were hired during this particular year, who work in this particular department, and etc. So the procedure could get quite complex, but it still provides easy access for outside sources. And then, of course, we want to encapsulate our DML procedures. Typically for an insert procedure, your insert procedure should return as an output parameter the newly generated ID value. So if you're inserting an employee, the stored procedure would perform that insert, and it would also give you back the ID value of the employee that you just made. For update, we could include version control to compare the timestamp parameters, for example. We talked about that a few weeks ago when we talked about data integrity rules. So we can look at those. And same goes for delete. We can implement version control as well. Now, it really depends on what you have in your tables. So if your tables don't have version control, or if they don't have like auditing fields, for example, then you're not going to write that in your procedures. It wouldn't make sense. The procedures are supposed to reflect what you have in your tables. So I'm going to provide you guys with some templates for the standard stored procedures, but just keep that in mind that you'll need to modify it to match what your table's underlying structure is. Now, there's an option that we set in stored procedures called no count. No count indicates whether or not you send a message or retrieve the number of rows affected by your actions. So no count means don't count the rows affected. And with a select procedure, we want to set no count to on, because in a select procedure, we don't need to know how many rows were affected by our select. So we can save traffic that way. But for action procedures, we should set no count to off. Now it's kind of funny because it's a double negative, right? No count. So if we're setting no count to off, it means we are counting the number of rows affected. The client-side objects depend on those messages for that rows affected information. This is the easiest way to communicate the success of a procedure. For example, if you're running a procedure that's supposed to delete something, and the delete procedure comes back and says 0 rows affected, it means that nothing got deleted. Your delete procedure failed for whatever reason. So this is the simplest way to let our client know whether or not our action procedure worked. For a select procedure, we would know whether or not it worked based on whether or not we got any results in our select statement. So, we're not altering anything. Affected rows is not a good way to tell whether your select procedure worked. So we can turn the counting off, which means that we set no count to on. I know it seems a little backwards. All right, so the standard procedure recipes, these are guidelines for creating standard stored procedures, and these particular examples are based on the following assumptions: that the table has an integer identity primary key. Now we know that's not always the case, but in this example, that's what we have, a table that has integer identity primary key. This table has a timestamp field for concurrency control, and this table has auditing fields called updated by and updated on. Now, as a side note, if you also have created by and created on, when you perform an insert procedure, you would set them both to the same thing, right? That created by and updated by would be the same if this is a brand new record. And just a final note to remember, write your procedures to match the data that you have in your tables. Okay, so here's the simplest procedure. This procedure says table select all. So we follow this recipe that creates a procedure, the name of the table goes here, and then select all. When we're doing a select procedure, we set no count to on, and we would select all the fields from either the view or the table. So if, for example, we were to make this for our employee table, if we have a view that encapsulates employees, we can use that, or we can use the table directly. You want to make sure that you select all the fields from that viewer table. However, you have two options here. You can either do select star, or you can list all the fields by name. Now, I said earlier, you might want to eagerly load lookup and summary values in a view. So if we have a view that includes all of that, this procedure is as simple as saying select all from view. So as an example, we're going to use our employee tables. So I'm going to switch to username company, and I'm going to select all from our employee table to start. So this is where we start out with my version anyway that I have right now of our employee table. And you'll notice it doesn't list the department or any summary fields. Now, in a previous lesson, we talked about views. So I'm going to create a view for the employee table, BW employee details. And this is going to select everything from employee. So I'm going to say employee.all. And it's also going to select the department name. And it's going to also select employee first, with a space, and employee last as employee full name. Now I'll write the from statement. And I'll execute the select statement first. Oh, I forgot a plus sign here. That should clear up. Here we go. So now we have a view that gives us lots of employee information. We have all the employee stuff, plus the department name, plus a nice summary field here. So if I create the view employee details, now I can use that view in my select all procedure. So let's move down. I'm going to follow this template and say I'm going to create a procedure that says employee, so that's the name of the table, and then select all. The begin and end are optional. So we're going to say we're going to set no count to on. We always do this for select procedures. And then I'm going to select all from BW employee details. Now, if you don't have a view, you could just take this and perform that here instead. So either way, if you already have a view, then you can use it. If you don't have one and you don't think you need one, then you can just write a typical select statement. So you want to make sure that you're including those lookup fields, anything you think that will be useful. I mentioned this in a previous video as well. We're trying to avoid multiple trips back and forth with different calls. So we want to be greedy and eagerly load the data that we think we're going to need. Okay, so let's revert this to selecting from the view. My select all procedure is now created. So now if I say, okay, client, sure, you can take a look at our employee data. You can display it on our website. You can make it available as a web service. All you have to do is execute this procedure. Say exec. Helps if you spell it right. There we go. So by executing the procedure, this code runs, which uses the view behind the scenes. This is all the client needs. So we'll see once we get over to our client side, we're going to start with writing SQL code in our client just because it reduces the level of complexity. But by the end, my goal is that our client is just going to use the stored procedures. So the client doesn't need to know the name of the tables. It doesn't need to know the name of the fields. It doesn't need to know how the relationship works. It doesn't need to write any join statements or anything like that. All it does is just call the name of this procedure and it gets the data that it needs. It's a really elegant solution. Let's look at the next procedure. Select by primary key. So this is selecting one. If we wanted to select one employee, for example, we could select one employee. We just have to specify the primary key value. In this case, it's some kind of ID value. So the select statement is similar, but notice now there's a where line. And the where line should refer to the primary key of the table that you're trying to select from. So let's, let's move down underneath this exec statement. So we're going to create a procedure, the name of the table, and then select by ID. Now we need the input parameter, telling it which employee ID to select. So we have the emp ID. Now I do want to point out that it really simplifies things for us in the long term if we make our parameter names the same as the names in the fields. So, I could call this thing E or X or anything, but it really simplifies things in the long run if we make sure that the parameters have the same names as the fields that they reference. And once we get over to client side, you'll see why that is. So we're going to make a parameter for emp ID, and then my as statement is going to be very similar. We always set no count to on, and then we're going to select everything from that view or from the table, but we're going to add a where line that says where employee ID equals our parameter value. Now, this thing is giving an angry underline because of the lack of go statement. So I'm going to put the go statement in there, and then we will create the select by ID procedure. And when I execute it, you'll see I can't execute it on its own. I need to provide a value for emp ID. So which employee do I want to see? Okay, well, show me employee number 6. There's one single employee record. And if I put it in a different employee ID, it'll show me a different employee record. So this is passing it by position, or we can pass it by name, like that. So there's 2 examples of select procedures, either selecting everything or selecting just one thing. Now let's take a look at some DML procedures. This first one is an insert procedure. We take input parameters for every column. So if we want to make an insert procedure to insert a new employee, we want to make sure that we take an input parameter for every field in the employee table. So let's take a look quickly at our table columns. Employee here has the columns of emp ID, emp first, emp last, title, salary, start, department code, and this one here is union dues, which is one that was generated on, I believe it was the last test. Now this is a computed field, so we don't need to specify a value ever, and we actually can't specify a value for emp union dues. So keep that in mind, that you need to take input parameters for every column except those columns that are automatically generated by the table. So we don't need an input for union dues. We don't need an input for emp ID because this thing is an identity field that's generated automatically. The other thing to remember about insert procedures is that you use an output parameter for the primary key value. So we want to know what ID was generated if it's auto-generated. Now, if your primary key is not auto-generated or an identity, then you would take it as an input parameter. So again, you have to write these procedures to match up with what's in your tables. Let's write this one for our employee table. So I'm going to create a procedure. Notice the naming convention's always USP underscore the name of the table and then the name of the action. So we say employee insert. Now, the parameters for this, I can just look and copy them from here. So we're going to say emp first, varchar 25. I'll pause the video while I type the rest. Okay, so I've typed the rest of them, all the names and their data types. Notice I've left out union dues because that's automatically generated or computed column. And the other thing is we have to consider defaults. So for example, emp title here, this field allows nulls. And that means when we're inserting an employee, we don't have to provide a value for emp title. But in this case, if I don't have to provide a value, then I'm going to assign null as the default value. So any fields that allow nulls, we want to allow nulls in our procedure as well. Now in this example, department code can also be null. Make sure that you check on that. Most of the time a foreign key field would have a not null. In this particular example, it does allow nulls. Your version of employee may be different to that, so just keep in mind that you want to look out for that. All right, and then the last thing that we do for an insert procedure is we have an output parameter for the newly generated primary key value when the primary key is auto-generated, an identity. Okay, now our as, this is where we write the insert statement. Thing to remember about insert procedures, we want to count the number of rows affected. This is how we can tell if it worked or not. So I'm going to set no count to off. We do want to count. So we do this for action procedures. Insert, update, and delete. So we set no count to off, and then I'm going to insert into employee. Now I could insert through the view as well. So keep that in mind that we could insert through the view, but I want to do examples going both ways. So I'm going to just insert into our employee table. Now here's our values. Because we may or may not have values for all of this, I want to make sure that we name all the fields and keep everything in order. So I'm going to say emp first, emp last, emp title, emp salary, emp start, and department code. I'm going to provide a list of fields. It's just a little bit easier to be specific at this point because then later if our employee table ever changes, we don't have to worry about our insert statement becoming invalid. Okay, so our values are the parameters, emp first, emp last, and so on. We're at the E here. So we can perform the insert statement and the values, oh, did I miss one? I did miss one. I missed emp start here. I don't know how I missed that. That's okay. The red underline is very helpful, indicating when I missed something. So here's our insert statement. And once it's inserted, there's one more step that we want to do, and that is to find out, well, what is the ID of this new employee? And so we're going to set that value to the scope identity. So we're going to select it, ID equals scope identity. So we've looked at this function before. Tell us the most recently generated ID value in this scope. Now there are other ways to get the most recent identity value, but it's good to use scope identity because it makes sure to look in this procedure. So if on the off chance that somebody else is inserting and it just happens to be right in between these two, it still will make sure that it's looking in this current scope. Now, we're going to get the scope identity, and as an extra mode of safety, we're going to make sure that this only happens when we actually affected a row. So this is why we want to make sure that no count is off, because we want to make sure that we're counting rows affected, and if one row was affected, it means that yes, we did insert a new employee, so then therefore get the scope identity. If you try to get it and the insert failed for some reason, then you would get an error message if you tried to execute that. So this is an added level of checking just to make sure that you're only going to grab the scope identity if the record was successfully inserted. Okay, so there's our template for the insert. Now the one on the slide includes those audit fields. Now typically if you had auditing fields updated by and updated on, you would set updated by to null as a default, And then in the procedure code, we would set it based on the logged in user. So we could set it to unknown if they have a null value, or we could assign it to the current logged in user. And then we could use today's date and the updated by to fill in those values in the table. Now my employee table doesn't have them, so I'm not going to shoehorn those fields into my existing table. I would only include them if they were part of the table. All right, here's an update procedure. It's very similar. We again need to take input parameters for all of the fields because you never know which ones are getting updated and which ones are not. Now, when we talked about concurrency control, one of the options for concurrency control was checking all of the old field values against the new field values. But it turns out it's quicker just to update everything than it is to assess each field and see if it changed and then only update the ones that are changing. So it's a lot simpler just to pass all the parameters and update every field in the table. So let's write an update statement, or an update procedure rather, for employee. Now, very similar input parameters, so I'm just going to copy and paste them. But I want to make sure that this time emp ID is an input, not an output. This is changing an existing employee. So emp ID is really important because that's going to be in our where line, making sure that we do actually change the correct employee record. So here, we're going to write an update statement. We're going to update the employee, and we're going to set employee first equal whatever comes in here, and then employee last. I'll pause it while I type the rest. Here we go. So I've typed all of the values. We're taking the input parameter, whatever value is passed in, and we're assigning that to the emp first column. And we're doing that for all of them. So whenever we call employee update, we're going to pass in all of the values. Okay. Now, the most important part of the update, the where line, where emp ID equals the input parameter. Now, if you have timestamps, you would also need to take a timestamp input parameter, and that would become part of your where line. And it would look like this. So if you have timestamps for concurrency control, this is how you make sure that not only are you updating the right employee, but you're updating the right version of the employee. Because if you have, say, version 1, and then somebody else has come along and changed it and it got moved to version 2, you're saying where employee ID equals this and timestamp equals version 1, it's not going to find a matching record, so it's not going to perform the update. So this is how the timestamp performs concurrency control within the stored procedure. Now, our employee table doesn't have a timestamp field in it, so I'm just going to remove this from the example, but I wanted to give you an example of how that would work. Okay, so I'm going to execute these create statements to create the insert and the update procedures, and then we'll try executing them. Let's execute the insert statement first. Now, you can see how the IntelliSense is helping tell me which fields I need. I can pass them by name or by position. So let's see, we're going to put in a first name and a last name and a title. Let's see, and a salary and a start date. And a department code. And then we have this output parameter. Now we know that we need to provide a parameter, and we need to mark it as output. I'll just hit enter on this so that we can see everything. we have to make sure that we declare this before we call it. Whenever we have output parameters, they need to be declared beforehand. Same data type. And then after the fact, we'll be able to print out a message, something like the new employee ID is. So I can execute all of this code. And oh, I've got a data type conversion error, but that's okay. It still did work. I'll do it again. I'll make Bob 2 Smith 2 and do this. So we get the new employee ID is now 10. And if we take a look at what's in the employee table now, see down at the bottom, I've got 2 of them that I just inserted twice. So every time you call exec and pass them values, the values got inserted into the table. And it returned to me the new value for emp ID. Okay, now what about the update? I'm going to update employee number 9 here to change something. Let's see, we can change intern to, I don't know, junior programmer or something like that. So I'm going to update the employee by calling the update procedure. Now when I call the update procedure, I have to pass values for all of the parameters because remember, everything is going to be updated. So if I pass 9 for the employee ID, and the first name isn't going to change, and the last name isn't going to change, but the title changed, so we can change that title, and maybe because Bob got promoted, we will update his salary to $55,000, and the start date isn't going to change, and the department code isn't going to change either. So we have, I'll just hit enter here so we can see everything, the update statement. So I'll execute that to update that record. And you'll see how this record number 9 here will change. So I'll execute the update and we'll review the changes. So now we have this record with a new title, a new salary. All right, the last one on deck is the delete procedure. So let's move on here to our slides. Delete procedures, I think, are the simplest one. They should only delete one record at a time. So all you need to do is specify the ID, and if you have a timestamp in your table, then you can specify the timestamp as well. But you can see this is a lot more simple because you don't need to know any of the other information. All you need to know is the primary key of the record that you want to delete. All right, so let's get the delete procedure in here. We're going to create procedure, the name of the table, and then the name of the action. We have one input parameter. We're going to set no count to off because the count is going to indicate whether or not it worked. And then we're going to delete from employee. Don't forget the where line, otherwise you'll end up deleting everyone. And that's all there is to that. To test it out, we pass in the employee ID. I'm going to delete employee 10. Now before I do this, we'll just refresh our memory and we can see how we have 2 Bob Smiths, right? This was the second one. This record isn't needed. We're going to delete it. So I'm going to call delete and remove employee ID 10. So I'll execute that procedure. And then when we select all from the employee, you can see that that record is gone. Now, there are some other common procedure types other than those main 5. So the main 5 that we see are insert, update, delete, select all, and select by ID. Another really common one is what we call a list style stored procedure. This typically selects two fields from a table, the ID or the primary key, and a summary field which summarizes the data. And we use this client side for populating a combo box or a list box. We most commonly would use it on a foreign key field. So consider this. Let's say you have a client that allows you to insert new employees or update employees, and we know that we have to put them into a particular department, right? We had to specify a department code. And if I specify a department code that doesn't exist in the department table, that's going to throw an error. Like if I put in something like that and it doesn't exist, then we're going to get an error. So we want to prevent users from doing things like that. And the easiest way, client side, to control the choices that a user has is to provide either a combo box or a list of radio buttons or checkboxes or something like that. We can generate these lists from here. So for example, if I write this select statement, if I say select department code and department name from department order by department name, this will provide something simple that we could make into a drop-down list or a combo box on the client side, where we can choose from a predetermined list of departments. We need the codes because that's what becomes part of the insert or the update statement for the employee. And we need the names so that we can show users which one they're choosing. So something like this would translate well into a list-style stored procedure. Create procedure, department, so the name of the table, and then the word list. This is a very common action, so we create a procedure around it. Now when we execute that, we can get that list anytime we need it. Another common one that we do is filter by foreign key. In this case, we would do something like select employee by department. We would take the department code as the input parameter, and then we would show all employees in that department. And a more complex one that we're going to do later on in the course, if we have time, is called a select by X, and it allows us to filter by many different criteria and bypass filters that we don't want to use. So we're going to look at that later after we're done building our client application. So here's an example of the list style stored procedure. One of the most important things about a procedure that generates a list is make sure that you include the order by line. Because if you're making a drop-down list, it's very important that it's in some kind of meaningful order, usually alphabetical order, but I mean, if those things are numbers that you're showing, put them in numerical order. Or if they have some other kind of logical order, then you make sure that you order the data in a meaningful way. Now the last example that we'll do is a filter by foreign key. So let's do employee select by department. What I want to create is a procedure that takes a department code and shows us a list of employees in that department. Now the select statement that it would encompass would be something like this. Where we provide a department code and it'll show us all the employees in that department. And if we provide a different department code, it'll show us a different list of employees. Now, this thing is going to be an input parameter. So when we create the procedure, employee select by department, we're going to create the input parameter for a department code. And we'll be able to, let me just indent this, we'll be able to put in the parameter here. So I'll create the procedure, and then we'll practice calling it. Employee select by department, and I'll provide a department code. We can see the employees in that department. If I provide a different code, we can see the employees in that department. Now this department doesn't have any employees. Let's see, what other departments have we got? Okay, so this is working well. Now, one of the tricks that we can do is we can create a procedure like this that accepts an input parameter, but also accepts if you don't put an input parameter. Now, right now, the way the procedure is set up, this input parameter is required. You can't run it without it. So you think, okay, well, the way to make it not required is by putting in a default value. So what can we use as a default value? Maybe null could be a good default value. So I'll alter the procedure to accept a null. Now, if I run it and I don't provide, what I'm going to end up with is showing all the employees where their department code is null. That still doesn't show everyone. How could we show everyone? Well, we need a where line. If we have a where line, but we want to show every employee, then we need something in the where line that is always true. Because remember, employee records only show up when the where line evaluates to true for that record. So the trick is we provide a flag value that would be always true for every record if you pass that flag when you call the procedure. So it's a trick to include all rows and bypass the filter. Now the flag must be a value that would never exist in actual data. So if your foreign key is an int identity, then it's obvious your flag is 0 because the 0 could never be the result of an actual real identity value. But here with department codes, it's a little trickier. We need to pick a department code that could never be in the actual data. And maybe we would even put a constraint on that department code field that would prevent us from creating a department with this flag value as its department code. So let's put in as a default a department code that's ZZZZ. Now, if I select all of the employees where the department code is ZZZZ, it's going to be empty, right? Select all from the view where department code equals that. We know that the result set is going to be empty. We want to make it so that it shows all of the records. So what I'm going to do is put in an OR line. Now we'll take a look again at this, where we're going to say the foreign key field equals the parameter, or if the foreign key parameter equals a flag value. So let's test this out. I'll just remove this. My department code is going to say this. So let's take a look now at how this procedure will work. If I call this procedure and I pass ISYS as the department code, because I passed a value, it's not going to use the default. Dept code is going to be ISYS. We're going to select all from employee details where the employee's department code equals ISYS. So that'll be true for some employees, not for others. And this here will always be false because ISYS is not equal to Z's. But when I call it with the actual Z's, or if I call it and leave the parameter out, then none of the department codes equal Z's, but the parameter does. So it's just a little trick that makes it true for every record if you pass in that flag. So let's try out the new statement if I pass ISYS. It works to show me all the employees in information systems. If I do it for accounting, it should show me all the employees in accounting. That's what we're expecting. If I leave the parameter out, it'll use this default. So if I run it without the parameter, You can see how now it shows me all the employees, because this is always false, but this one becomes true for that one special case. So that is a way to bypass the filtering by providing that flag. Now, the only way that this can break down is if you enter in your department table a ZZZZ department. Okay, so this comes to the end of our lesson about standard stored procedures. Now you have everything you need to know in order to be able to finish your current lab. If you have any questions about this or any other of the topics in the course, feel free to email me. Otherwise, I hope you have a great day.